Good evening. How are we tonight? I'm fine. Welcome to Financial Management. Good evening. Good evening. We're on assignment three. We did the first part for tabulating our weighted average cost of capital. So today we'll be looking at part B, right? Where they want us to calculate the net present value investment and advise whether the investment is acceptable. So this part of the question deals with investment appraisal. This is how businesses choose which projects to invest in and which projects not to invest in. All right, that's investment appraisal, right? You evaluate each project, you see if it's worthwhile or if it's not. So there are various techniques. So today we'll be focusing on the net present value. What the net present value technique does is you're going to forecast future cash flows that you're going to be expecting to get when you indulge in this project. Then those future cash flows, you're going to convert them into the present value. All right. So here, it's also a bit of revision on the time value of money. All right. So I repeat again for the net present value technique, we're going to first forecast the cash flows that we expect in the future and convert them into the the value for today, basically the present value. Are we okay with that, colleagues?
Okay, okay.
So the main thing that we're doing here is first we want to forecast our future cash flows. So let's just read through the question. Right? Can somebody read for me? This is an essay. All right. This is an essay. By the time I'm done reading, I won't be able to explain. So it's oh yes, yes. Are we able to see the screen? Okay. And you can read for us then.
I was removing it, but it was what?
Mr. Benjamin, from here, from the top, yes.
Um, I don't like connecting those things there. That's the thing. And especially, but so what I can do for you.
Okay, wait, you can skip this part. Just read this last part. You can skip this. Yes. Uh-huh. Mm-hmm. Yes. Yes. 150. the, you can hold up there. You can stop. You can stop. That part was for yeah. That part was for weighted average cost of capital. Yes. So here, the story that is going on is this company wants to buy equipment costing 820,000 so that it can produce a new game called Push. All right. So we forecasted in year one, we want to produce 160,000 units. In year two, 63,000 units. Year three, 60,000 units. Year four, 58,000 units. All right. This is the selling price of the game. As you can see in year one, 26 kwacha, year two, 24, year three, 22, year four, 21. All right. We've also got information on direct materials cost and other variable production costs here with our fixed costs. So what we're going to do here is we're going to make a marginal costing profit statement. All right. The table that you're about to see, which we're going to start doing, that's called the marginal costing profit statement. All right. This question is a hybrid of cost accounting and financial management. All right. So this is how we're going to obtain those cash flows through this profit statement. That's how we're going to obtain the cash flows. Okay, so let me make this table here. Microsoft Word has expired on me, so I'll put it in after the class. So I'll just use the board for today. So we have our years. We have year zero, year one, year two, year three, year four. All right. First thing that we're going to put in our the first item is the selling price per unit. All right. Selling price SP per unit. All right. Year one, it's 26 kwacha, 24, 22, 21. Year two is 24. Year three is 21 kwacha. Year four, this is 21 kwacha. All right. After you list your selling price, the next thing you're going to tabulate are your variable costs. All right. So you're going to say variable cost per unit. So here you make a line here, costs. All right. So we have our variable cost per unit, VC per unit. The first variable cost is direct materials. I have to put actually here, direct materials, DM. Okay, we come back to this table. All right, so it is 5.2 kwacha per game. All right, so here I'm going to put 5.2, 5.2. How are you? Okay, okay. So how you identify? Yes, how you identify if you're going to need to forecast the future cash flows? It's very simple. It's just through this information here. Here, all right. because the main thing that we're trying to get is our cash flows, which we're going to expect in the future. Remember, we're using the net present value technique. So we want to get those future cash flows and then we convert them into their present values, right? So since the cash flows are not given to you, you have to tabulate them for yourself. So when you see information like this, and you've seen a question here which is saying either calculate the net present value or the internal rate of return, then you know that okay, with this question first, I have to get the work, which will be my discount factor. Then I have to tabulate my cash flows, then convert them into the present value so that I can do the net present value technique. Okay. Yes. Your network, Mr. Benjamin. Uh-huh. Mm. Oh, actually, I should have put five. Error of omission, yes. Yeah, it's just an error of omission. Thanks for pointing that out. Because I believe questions started forming in our heads. How has this 5.2 come? Okay, you list out your variable, the direct materials. Next, our other variable costs, all right, 5.67 per game. All these are per unit, okay, per unit, all of them. 5.67, 5.67. So what's happening right now is first we're going to tabulate our variable costs and deduct them from our selling price, and we're going to get what is called contribution. All right, contribution. Right, contribution equals the selling price minus the variable costs. That amount you remain with is supposed to cover your fixed costs. All right, contribution is the money that is used to cover your fixed costs. All right, the purpose of contribution, especially for management accountants, contribution will tell you how many units to produce so that you can be profitable. All right, how many units you can produce to be profitable. And if after you deduct your selling price from your variable costs, and that money that is left is not able to cover the fixed costs, the contribution is not able to cover the fixed cost, then you have to either change your selling price or change your variable costs. Okay? So contribution is just the money that is meant to cover the fixed costs. Are we okay with that, colleagues? And it helps the business know how many units they need to produce to be profitable. So what we're going to do, we're going to add 5.12 plus 5.67. That amount we get, we deduct it from 26. So we can get our calculators. 5.12 plus 5.67. In your calculator, just put it like this: 26 minus 5.12 plus 5.67. All right, 0.67. Yes. 15.21 for year two. Year two. Year two, 24 minus 5.2 plus 5.67. Year three, 22 minus 5.12 plus 5.67. Okay, let me just submit someone in. 11.21. And then for year four, 21 minus 5.2 plus 5.67. 10.21. All right, so we've got our contribution per unit. Now, the next thing I want to tabulate is our total contribution. You see what our total contribution is going to be. After we find out our total contribution, we'll deduct it from any fixed costs that the company is going to incur. All right. So the first thing that we do, we list the units we expect to produce. So we're going to say in year one, we expect to produce 160,000 units. Right. So your total contribution, you're going to multiply 15.21 times 160,000 units. Fifteen point two one. Mm-hmm. Yeah, it's given in the question. It's given here. And a lot of times they like to confuse students with here sales and production units. So you start thinking, are these the sales? No. Moment you just see units here, this is how much you want to produce. All right. So do not let this term confuse you. All right, thinking that these amounts here are the sales. No, it's how much you expect to produce. So 15.21 multiplied by 160. 2 million. Okay. We got on in the next year, we expect to produce 63,000 units. So you say 3.21 times 63,000. 832,230. 832,230. Yes. Not decimal places. Okay. Um, Next one, 11.21 times 60,000. So in cost accounting, you also find such questions also. Because investment appraisal is both in financial management and cost. Yes, Mr. Benjamin. 11.1 times 60,000. Excuse me. Uh-huh. Hey, was that network? You were cut off for a long 672. Eesh. Anybody else? I think he's been kicked out. Hmm. Let's grab our calculators, colleagues. This is not corporate governance where we sit in and listen. 672,600. Then 10.21 multiplied by 58,592,108. So as I said earlier on, contribution, this is the money that is used to cover your fixed costs. Yes, as I was saying, contribution, this is the money that is used to cover the fixed costs, right? If as a company you see that your contribution cannot cover your fixed costs, right? It's either you need to produce more, maybe you need to increase your selling price, or maybe you need to reduce your variable costs. Okay. So on this figure here, 10.21 times 58,000, 592,108. All right. So the next segment is our fixed costs. Now, these are we're getting the total fixed costs. We're not getting the per unit fixed costs. So here, fixed cost is 4.65 per game. All right. So if you produce 160,000, your total fixed cost is going to be 160,000 times 4.65. What do we get? 160,000 times 4.65. 744,000. Okay, we go to year two. 4.65 times 63,000. 4.65 times 63,000. Okay, 292,950. Yeah, someone raised their hand. 4.65 times 60,000. Someone raised their hand. What's your query? Okay, so 4.6. Uh-huh. 179,000. Okay. All right. And then 4.65 times 58,000. 269,700. All right. The next thing that we include these advertising costs. Year one, 600,000. Year two, 151. 600,000. In year two, they said it would be 151,000. Then year three, year four, there's no advertising costs. All right. So now we deduct, all right? We start with year one, 2,433,600 minus 744,000 plus 600,000. 2,433,600 minus 744 plus 600,000. Close brackets. All right, like this. Minus 7 4. One, zero. Uh-huh. Okay. So what we have tabulated here are our cash flows before tax. All right. The value that we're getting here, these are our cash flows before tax. 832,230 minus 292,950 plus 15100 close bracket. Okay, 388, 280. The next one, you says you do 832,230 minus open brackets this amount plus this amount close brackets. Another way you can also do it, you can just do 83230 plus negative 29950 plus negative 1500. Why we're calling them negative, because these are costs, money coming out of our pocket. That's why they're being put in brackets. So either way, you still get the same answer, right? You can add this plus these negative values, or you just use this value, subtract it, you open brackets and say 292,950 plus 15100, close brackets. I hope that has answered your question. 388280. 672,600 minus 279. Okay, 393,600. 393,600. All right, then 592,180 minus 269,700. 322,480. All right, this represents our cash flows before tax. Okay, this is can also be thought of as our profit before tax. But here we're going to take it as our cash flow before tax. So the next thing that we do, we've been told that tax is charged at 30%, all right, per year, and tax liabilities are settled in the year they arise. So we'll be getting 30% of each of these values here. Okay. So we're going to say tax at 30%. So what is 30% of 1,089,600? Yes, Mr. Benjamin or Mr. Ernest. 30% of 30% of 388,280. Hello. Cash flow before tax. First, these are the tax charges we're going to incur. Then after we subtract these, we're going to get our cash flows after tax. And those are the ones that want to use for the net present value technique. Mm-hmm. 30% of 388 to 80. Mm-hmm. Okay, 484. Then the next one, 30% of 393,600. So here's a question, colleagues. How can we remember how to do this table? Because you have seen it's a very big table. How do we remember all the steps in this table? As well, think of that. 30% of 32248. 96,744. So now we can get our cash flows after tax. All right. These are the ones we are going to use for the net present value. All right. We're going to discount those cash flows, and our discount factor will be the weighted average cost of capital. So let's tabulate our cash flows after tax, or you can say net cash flow. Now, just hold on before we go further. Remember, there's a column here for year zero. All right, year zero. Remember, we're purchasing this machinery so that we can be producing the games. All right. So under year zero, once you reach this part for the net cash flows, under year zero, you're going to put that cost of the machine, which was how much? 820,000. Yes. Yes, 820. So here you represent it as a negative because remember you are paying for this machine, so money is coming out of your pocket. Right? So 820,000 here. Okay. So 1,089,600 minus 326,880. Okay, 762. 762. Okay. Yes, Mr. Alec. No, 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 no. This 820,000 is the cost of the machine. Okay. So remember, when you're doing these questions in the exam, colleagues, especially these parts where they're in the paragraphs, please highlight or underline these numbers. Okay. Highlight and underline so that you don't miss any numbers or any important information. Miss Ines, just read for me the number again. Sorry, I was distracted there. 762. Okay. The next one, 38,000 to 388,280 minus 116,484. All right, this is an 8, 484. 27. Uh-huh. Okay. 393,600 minus 118,080. 272,520. And the next one, 322,480 minus 96,744. 222,480. All right. So now 736, we have got the cash flows, which we are forecasting. All right. Remember, this is money we'll be receiving in the future. So now with the net present value technique for investment appraisal, all these all this money you'll be receiving in the future, you're going to convert it into its present value. All right. So we're going to say our discount factor, DF, which is our weighted average cost of capital. Excuse me. DF. What was our work? We calculated 10%, huh? 10%. Okay. So this is where the tables will come in handy. Okay. In the exam, using the formula will take time. Okay. It will take time when you use the original formula in the exam. Let me just get the tables. We go to our present value tables, all right? Please make sure you know the right table. Worst case scenario is you go to this annuity table and you put these discount factors, all right? So we go to our present value table. Those who want to use the formula, this is the formula you'll use. All right, 1 plus r to the power negative n. Your r will be 10%. The n will just be changing. All right. So in year 0, since it's to the power negative 0, so in year 0, all right, our discount factor is 1. All right. Discount factor is 1. And it is always going to be like that. Always. We come to our table here, 10%. This is our discount factor, 10%. Year 1, 0.909. Year 2, 0.826. Let me just jot them down so that I'm not coming back to this table. Year 1, 0.909. 2, 0.826. Year 3, 0.751. Year 4, 0.683. All right, so we put them in. Year 1, 0.909. Year 2, 0.826. Year 3, 0.751. And year 4, 0.683. So now we can tabulate our present values. To get our present values, multiply the cash flow plus the discount factor. So we're going to say up here, PV present values. So for the net present value, if after you tabulate the present values and it gives you a negative value, then the project is not worth it, right? If your net present value, when you tabulate and you find that it is negative, right, the project is not worthwhile, right? But if your net present value is positive, you can accept the project. All right. That's the rule for the net present value. Negative, reject. Positive, accept. So we're going to say here present values PV. Negative 820,000 multiplied by 1. Negative 820,000, right? All right. Then year 2, 762,720 multiplied by 0.909. Okay. So let me write it just 693. Point. Mm, that's more. 762 720 multiplied by 0.909. 693 312. Mel's here. I had point. After the 693, I had point. 271,796 multiplied by 0.826. Okay. Let's round it off to make life easy. Hi, colleagues. We can round it off, right? So that life is easier. Okay. We can just leave it like this. The next figure, and I'm just also doing it because I need space. The numbers will be too close together. 27, this number multiplied by this number. Yes, yes. Okay. The next one, 272,520 multiplied by 0.751. Two zero. Okay. 20. Uh-huh. 6. All right. And then 225,736 multiplied by 0.683. Where's the point coming first? 154, comma. Okay, we'll round it to 178. All right, so the moment of truth. All right, we add these present values. So you say negative 820,000 plus 693, 693,312 plus 224,504 plus 204,663 plus 154,178. What do we get, colleagues? So it's a positive value. It even looks like it's going to be a positive value. So this is positive. Okay, so round it off for me now. 456. Yeah. Okay, 6. Okay, okay. Hey, yes. Since we are purchasing, okay, the why it's negative because you are purchasing equipment, so it means some money is coming out of your pocket. That's why I'm putting it as a negative. Then these positive values, this is money coming into your pocket. Okay, so that's why this one is negative because we're saying if we buy this machine for 820,000, right? These are the cash flows we expect in the next 4 years. Yeah. Mhm. or net cash flow. Okay. Okay, 456, comma 657. Okay. So as director of finance, right, you can gladly accept this project, right? But remember, as we learned in business in environment, business is uncertain, all right? We might not even get these sales we're expecting, all right? We might not get them. So, yes, this is just these are just estimates. All right. So since our net present value is um, positive, we accept the project. Yes. Yes, you're right. Since the net present value equals this, and since it's a positive figure, we accept the project. Is what you write. Any questions before we go to the internal rate of return? So that we finalize this assignment today. So basically, the internal rate of return is just more like a continuation of the net present value. If you remember how we did it here for the work, how we did our internal rate of return, that's the same thing that we're going to do. The only difference is since our table is upside down, all right, so these narrations we won't, no, actually it's better we put it in this format. So here instead of market price, all right, we're putting the cost of the machine. Here, this time we're not having any annuities. Well, we've seen the cash flows are different each year. So we're going to list for year 1, year 2, year 3, year 4, year up to year 4 years. There is no redemption value. So we just end at year 4. All right. Oh, let's see. When the net present value is positive, we wait, tend to forget those rules. Yes, if our net present value is positive, multiply the discount factor. So you use 20 and use 20 or any discount factor around that area. Because with the internal rate of return, you need two net present values. One should be positive and one should be negative. So we come back to our here on our table. We're going to say discount factor at 20%. All right, so we're still going to multiply it with these net cash flows. Okay, so let's go to our table. We get our discount factor. Where is this? At 20%. Yes, so here at 20%, let me just jot them down. Year one, 0.8333, then 0.694, 0.579, 0.482. right? So always in year zero, the discount factor is 1, okay? Because once you replace that negative n in this formula here, anything to the power 0 is 1. For year 1, our discount factor is 0.833. About 8333. Year 2, our discount factor is 0.694. All right. And here, year 3, 0.579. Then year 4 is going to be 0.482. Yes. Yes, they're from the table. Under the, you're talking about here. Oh yes, we have. Yes, 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 we have. Yes, yes. Here, Mr. Benjamin. Yes. So what do you do in case, let's say, you're doing this question, right, and then you find your work is 23%, and on the table there's no 23%. What do we do, colleagues? Yes, use the formula. All right, so present values, right? So we're multiplying our net cash flows with this discount factor, okay? So negative 820,000 multiplied by 1, we get negative 820,000. 0.833 multiplied by 762,720. Let me highlight what we are multiplying so that there is no specializing in confusion. These net cash flows by our new discount factors. Mm-hmm. 635. 346, right? Next one. Once. Mhm. The next one. Okay. Mm. Mm. Oh, yes, 188,626. Yes, I've also got that. Yes, it's okay, okay. One, eight, eight, 626. The next one, mm, and then the next one. I'm foreseeing we'll need to increase the discount factor. 20% won't 108,05. Okay, let's try these numbers. If it still gives us a positive number, we have to increase our discount factor, right? Because we need a negative net present value. So let's add these current numbers. Let's see what we get. We were positive, so we have to increase our discount factor. So now even the formula will have to come into use. All right. So I'm estimating, let's say, how big is the number? What's the number? What's the positive number? So that I can estimate which one, which discount factor I think can work. Mm-hmm. All right. 275. I think we use 30. 27. I think we use 30%. I think we have to use 30%. So we change our discount factor at 30%. All right. So we have to use the formula for the present value 1 plus r to the power negative n. So 30% is 0.3. 1 plus 0.3, that is 1.3. So for year one, you say 1.3 to the power negative 1. All right. Year zero, it's always going to equal to 1. 1.3 to the power negative 1. Year two, 1.3 to the power negative 2. All right. Year 3, 1.3 to the power negative 3. Year 4, just like that. So let me erase this part here so that we get our new discount factors. Things are bad because this is trial and error. I find if 30% doesn't work, you have to increase again. We might find we might even reach 100%. Mm-mm. What I can say, maybe if it's an issue of time, you just use that positive value. Obviously, the marker will understand. Mm. Yeah, so it means you have to try, even though you reach 1000%. So in the exams, colleagues, do not panic, okay? Once you see, usually one trick to use is once you see like these first two numbers, like hey, it's 600 and this one is close to 200. You already know these two have already approached in the 800s. This one has even gone off. So you can know that this discount factor is not working. Let me change. Okay. You can also just estimate yourself as you are using. You see the if the discount factors are leading you towards either a positive or a negative value. So yes, colleagues, 1.31, 1.3 to the power negative 1, 0.769. The next one. Okay, the next one. The next one. 0.455. 0.350. Okay, let's multiply them with our net with our net cash flows. Then someone on their calculator prepare that negative 820,000 as the cash flows are coming. If you see we're still on a positive number by number 4, which we have to change the discount factor. Okay, if we're still at a positive value by year 4, year 3, you have to increase the discount factor. Yes, what's our value? 0.769 times 762,720. 5439. Okay. The next one, 0.592 times 271, 796. Yes. Ah, 586. Huh? The net cash flow. Have you seen where I've pointed this arrow? Net cash flow multiplied by the discount factor at 30%. Yes. Multiply 0.769. I haven't heard any lady's voice tonight. Madam Chishimba, Madam, who else? Madam Clara, Madam Nelly. Are we are we following? Well, it just seems Benjamin, Ernest, and I think Ali who have been contributing throughout. 271796 times 0.592. Someone should be adding so that we don't get our hopes up. Excuse me. Then 0.455 times 272, 520. 9. Okay. Colleagues, let's see what figure we've reached by here. Then someone else, give me the value when you multiply 0.350 times 225736. Just hold on. How is it going? It's, it's positive. Okay. So let's increase. Let's make it 60%. Okay, 50. But I think 60 it would be definite. 60 I think will be definite. If it's not, mhm. If it's not, we'll go to 100%. Okay, so you can faint. You can panic actually. So we erase this. That's why, colleagues, once it reaches the internal rate of return, this is the point you use a pencil. All right. So it's how many marks? Or four? Okay. And if you capitalize on the other questions and you know you have hammered them, yeah, you can. Yeah, you don't really need to panic then. So it's now we do 1.6. That's a good one. I think time value, questions on time value. Time. Sure, sure, sure. We will restart. Just just remember, colleagues, time value of money. We're just changing the for finding out the present value of money that we'll be getting in the future. We're getting the future value of the money that we have now. That's the whole concept behind time value of money. So we'll go back to it. Do not worry. We'll go back. Yes, colleagues, 1.6 to the power negative 1, 1.6 to the power negative 2, 0.3911, 1.6 to the power negative 3, okay, 1.6 to the power negative 3, 1.6 to the power negative 4, okay. So we multiply each of these discount factors with the net cash flows here. So 762,720 minus 0.625. Mm-hmm. I've written them down. My screen wasn't showing. Okay, okay. Okay, so do point 625 times 720, get 476 700. Right. Please, in the exam, do not try to attempt to cook figures, manipulate figures so that you get a negative. They will check. 0.391 times 271,796, 106,272. 0.244 multiplied by 272,520, it's 66,494. 495 to round it off. Then 0.153 times 225,736. 225,736 multiplied by 0.153. You get 34,537. 538, actually 538. Okay, this one it looks promising. We can add. Okay, negative Okay, so once we've got our net present values, we now use the formula to calculate our internal rate of return, right? Remember, we label our A%. A% is the lower discount rate, which is 10%. B% is the higher discount factor, which is 60%. NPV, the net present value with the lower discount factor, NPV A% is 456,657. And get the net present value with the higher discount factor, NPV B% as negative 135,995. So we put our formula. The internal rate of return equals A% plus NPV A% divided by, let's see, divided by NPV A% minus NPV B%. Right, open brackets, B% minus A%. So we substitute so that, so if our internal rate of return, we're going to be comparing it with our cost of capital. The weighted average cost of capital we calculated, if our internal rate of return is greater than our cost of capital, we accept. Our internal rate of return is less than our cost of capital, we reject. So A%, this is 10%. Okay, please do not convert them to decimals because once you get your answer, you have to convert it back into a percentage. Over 456. Remember, order of operations over and colleagues, which one do you think is the most reliable technique for investment appraisal? Because the internal rate of return can give you a different interpretation. And then now you start wondering. This one is saying I accept, this one is saying I reject. Which one should I trust more? Which one would you trust more as a director of finance? Minus NPV B%. You are doing investment appraisal for your company. Net present value gives you, says yes, but then the internal rate of return is saying no. As director of finance, what would you choose? But I read in a book, NPV is the most trustworthy, the net present value. It's more trustworthy. But we can research, colleagues, we find out. Because in real life, these things can happen, and yet you'll be director of finance. So if you don't know which one's more reliable, and you pick the less reliable one, and then you get losses, you get fired. So 456,657 minus, let's do this tabulation in the denominator. What do we get? Hello, are we there? 41%. It's greater than our. Okay, but okay. Colleagues, we're doing for our the sake of our other classmates. What's this tabulation? What does it give us here? 60. Yeah. No, it's okay. At least people should use different discount factors. Some can use 49, some can use even 100%. You can use 100%. Now I'm asking for this tabulation here. The ones who are moving with a 60% discount factor. The denominator, and then when you divide by the numerator. I just want the whole figure here. Then here in brackets, 60 minus 10, that is 50%. Mm, 0. Okay, 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 okay. Oh, 0.771. Okay. So 0.771 times 50%. Mm, 0.771 times 50. I'm not trusting that first. Let me confirm. Colleagues, are we also getting that? Yes, 38.55. That's why I was really skeptical about that value. You gave me a 0 point something, or you converted into decimals. Mhm. Yes, yes, yes. As I said, colleagues. Yes, yes. Okay. So 10 plus 38, this is 48.55%. That's our internal rate of return. So we compare it with our cost of capital, which we tabulated, which is our work. Our work was 10%. All right. Work 10%. So this This is greater than our cost of capital, so we accept the project. So you accept.